Alrighty, so this is our final lesson for surface area and volume. And we're looking at the volume of pyramids and cones now. And basically we just use a formula for this. So you can see that we have a formula here for the volume of a pyramid. And it's V equals a third times A times H. So A is the area of the base and H is the perpendicular height. And where have we seen this before? This looks very familiar. It's almost the same as the formula for finding the volume of a prism. Formula for finding the volume of a prism is V equals area of base times the height, the perpendicular height. The height that's perpendicular to the base. And the formula for finding the volume of a pyramid is a third times area of base times the height. So you can see that there's a relationship there. What that's saying is the volume of a pyramid is actually just a third of the volume of a prism with the same base and height. And don't worry if you don't see that straight away. All you need to do is memorize this formula over here, this V equals a third times area of base times height. But I do recommend that everyone watches the following YouTube video that I'm going to put up after this video. It's a really cool way of showing you that the volume of a pyramid is just a third of the volume of a prism. And it might help you to memorize it if you can visualize it as well. And aside from that, the video is just like awesome ASMR. So it's really cool to watch. Okay, but for these questions, we just need to remember the formula. So example 1, find the volume of the following pyramids. And you can see that these are different pyramids too. This first one is a rectangular pyramid because it's got a rectangle as its base. And this one over here is our triangular pyramid because it has a triangle as its base. But it doesn't matter what type of pyramid it is. This formula here, or this formula for volume of a pyramid, it doesn't specify what type of pyramid, okay? So it works for every single type of pyramid. And that's because you're finding the area of the base, and that's going to be different depending on what type of base it has. So for our first pyramid, let's write down our formula here. V equals a third times the area of the base times the height. And so we're going to need to find the area of the base first. So let's find A. Area of the base, well, in our case, we've got a rectangular base here. So in order to find this area here, we just need to multiply the length by the breadth. And you can see that the dimensions there are 20 millimeters by 25 millimeters. So our area is just going to be 20 times 25, which is 500, and it's square millimeters is the unit. Now if we want to find the volume, we can use that as our value for A. So the volume is equal to a third of A, which is 500 square millimeters, times the height of the pyramid now. So the height of the pyramid, I'll just change my color, is this height here. Okay, it has to be the perpendicular height, so it has to make a right angle with the base. We can't use this slant height here. We can't use any of these slant heights. It has to be perpendicular to the base. Just like with a prism, we need to use the perpendicular height or the perpendicular length. Okay, so that height there is 30 millimeters. So our volume, if we put that into the calculator, is just going to be a third times 500 times 30, which is 5,000. And we're talking about volume now, so it's going to be cubic millimeters. Okay, let's do our second prism over here. I mean, not prism, pyramid, my bad. Change the color for this one. So this time we've got a triangular base. So we know we're going to need to find the area of this triangle first. So let's write down our formula. V equals a third times the area of the base times the height. And we know we need to find the area of the base. So the area of the base, well, that's just going to be a triangle. You can see this triangle here. This is the area we need to find. I've kind of covered some of the dimensions there, but you can see that this is the perpendicular height of the triangle, 7 meters. And along here, this is the base of the triangle, 10 meters. You can see that it's perpendicular to the height. So our area for a triangle is half times base times height. So it's just going to be a half times 10 times 7, which is 35. And its area, so it's going to be square meters. Okay, so our A is 35 square meters. We know that now, so we can plug it into our original formula for volume, because we're not trying to find the area of the base, we're actually trying to find the volume. So volume is equal to 1/3 times the area of our base, which we said was 35 square meters, times our height of our pyramid now. So we're not talking about the height of the triangle anymore. We need to remember that this H in our volume formula is the height of the pyramid. So it has to go up to the top of the pyramid from the center of the pyramid. And you can see that that's 8 meters. So if we plug all those values into our calculator, 1/3 times 35 times 8, and it gives us a volume of 93.33 cubic meters to the nearest 2 decimal places. So we found the volume of both of these pyramids. That was pretty straightforward. We really just needed to use the formula.